Okay, in this video we're going to do the graphs of both the secant and the cosecant functions. So all the other trig functions so far have gotten their own videos for the graphs, but secant and cosecant, there's a reason I want to do these together. It's a good way to kind of tell them apart, and it's good to see it both at the same time together. So we're actually going to spend most of the time working on secant, and then cosecant is relatively easy to get after that. So we're going to use some graph paper here. If you want to follow along with some graph paper but you don't have any, click the link in the video description, and there'll be you can click that link and open up some graph paper and print it out and follow along if you'd like. Okay, so basically we're going to do the secant graph just like we did the tangent graph. We're just going to plot some points. Okay, but first, before that, actually, what we want to do, and this is going to help us out, just like with the tangent graph. So it's actually almost identical at the starting point to the tangent graph. Secant of x secant of x equals 1 divided by the cosine of x, right? So remember, remember with things like if you have a function something along the lines of y equals 1 over x minus 1, so if you want to graph that function there, then we'll just sketch that graph real quick. So x-axis, y-axis. So 1 over x minus 1, that's going to look kind of sort of something like this. Got that hyperbola looking shape, kind of like this. Okay, and we know that there is a vertical asymptote right here at x equals 1. Okay, because at x equals 1, okay, when x equals 1, the denominator is 0, you're dividing by 0, so you have 1 divided by 0, that's never, ever, ever allowed. So what that corresponds to is a vertical asymptote, okay? Well, similarly, if cosine of x is ever 0, then secant, the graph of secant is going to have a vertical asymptote, okay? It was the exact same thing with the tangent graph, because tangent is sine over cosine, so whenever cosine is 0, tangent has a vertical asymptote. Okay, well similarly, whenever cosine is 0, secant also has a vertical asymptote. Okay. So let's erase all this here. Okay, so now we're going to use that fact. So basically, where is cosine of x 0? So cosine of x equals 0 when, and we talked about this several times, whenever x equals 2k plus 1 times pi over 2, where k is any integer. Okay, k is any int. So I'll abbreviate integer for int. Okay, so k is any integer, and basically this is just a short way of saying x equals plus or minus pi over 2, plus or minus 3 pi over 2, plus or minus 5 pi over 2, and so on and so forth. Okay, so it's just a short way of saying that. That's all that really is. All right. So what we're going to do then, so basically, what does that mean? So cosine of x equals 0 when x equals all this. So so secant of x has vertical asymptotes at these values of x. Okay, so VA, using that as an abbreviation for vertical asymptote. So remember, vertical asymptote happens whenever the denominator is 0. Well here, secant is 1 over cosine. Cosine is 0 at these values of x. So that means secant has vertical asymptotes exactly at these values of x. All right, so we're going to plot those on our graphing paper first. So that's what we're going to do. Okay, so let's bring that back. All right, so we'll zoom in a little bit here. Okay, so let's see. Let's maybe set up a y-axis here. And we'll put our x-axis sort of in the middle-ish. You're probably not going to need all that space, but why not give it to ourselves just in case? Okay, so x-axis, y-axis. Okay, now we're kind of going to have to set up a scale. So the scale I want to use is every grid unit I want it to be pi over 6. Okay, so this right here will be pi over 6. This next one is going to be 2 pi over 6, which reduces to pi over 3. Okay, so 2 pi over 6 is pi over 3. Next one is 3 pi over 6, which is pi over 2. Okay, the next one is 4 pi over 6, which is 2 pi over 3. Okay, this next one here is going to be 5 pi over 6, which doesn't reduce. Next one is 6 pi over 6, which is pi. And is that as far as we need to go? Let's go a little bit farther. So pi, the next one, so this was 6 pi over 6. The next one remember each grid unit is pi over 6, so that's why I'm counting in units of pi over 6. So 1 pi over 6, 2 pi over 6, 3, 4, 5, 6, 7 pi over 6. 8 pi over 6, and 8 pi over 6 reduces, so there's a common factor of 2, and you'll get 4 pi over 3. 9 pi over 6 reduces to 3 pi over 2, and that's actually a good place to stop. Okay, so then the same exact thing going the other way, so this will be negative pi over 6, negative pi over 3, or 2 pi over 6, negative pi over 2, negative 2 pi over 3, negative 5 pi over 6, negative pi, negative 7 pi over 6, and negative 4 pi over 3, and then negative 3 pi over 2. Okay, so we have that. All right, so now I want to make the scale on the y-axis about the same, so it can't be exactly the same. We don't want to have it in terms of pi, but let's do it like this. So each grid mark is going to be 1/2 of a unit on the y-axis. Okay. So this will be 1. Okay, so this 1/2 unit, 1 full unit, then 2 full units, and then this would be 3 full units right here, and then 4, and then 5 up here. Okay. This is 4.5 right here. Okay, so then going back down this way, here's negative 1/2, negative 1, negative 2 right here, negative 3, negative 4, and then negative 5 right here. Okay. Okay, so that's, oops, all right, so there's our scale on the y-axis. So they're almost the same. Pi over 6, pi is about 3.14, so 3.14 over 6 is a little bit bigger than 1/2. So these grid marks are about 1/2, close enough to be okay. So anyway, now just like with the tangent graph, we're just going to start plotting points. So yeah, it could get kind of tedious, kind of dull. There's not really anything exciting happening. We're just plotting some points. But sometimes it really is the best way to go. Okay. But actually, before we plot some points, what we want to do now is plot asymptotes. So remember, well, actually erase it all on the board. But remember, secant is 1 over cosine. Okay, so secant of x. Oops, secant of x equals 1 over cosine of x. So secant of x is going to have vertical asymptotes whenever this denominator is 0, while the denominator is cosine. When is cosine 0? Cosine is 0 when x equals pi over 2. Okay, so right here at pi over 2 there's a vertical asymptote, so let's go ahead and draw that. Okay. So we'll come down this way also. Okay, so this right here is the vertical line, x equals pi over 2. Definitely should always label those. Okay, x equals pi over 2. And then cosine of x is also 0 when x equals 3 pi over 2. So that's right here. Okay, when x equals 3 pi over 2. Okay, so this here is x equals 3 pi over 2. Okay, so that's another vertical asymptote. Then there's 2 more. So there's one right here at x equals negative pi over 2. Okay, so that's this value of x right here. So another vertical asymptote, which we'll fill in right here. Yeah, let's maybe zoom out a little bit while we do this, just a little. Okay, so this here is x equals negative pi over 2. And then we have another vertical asymptote when x equals negative 3 pi over 2 because cosine of negative 3 pi over 2 is also 0. Okay, so another vertical asymptote here. Okay, and then we'll come down this way also. Okay, so if you want, you can keep labeling the x-axis beyond negative 3 pi over 2 and beyond 3 pi over 2 this way, but it won't be necessary for what we do in the video anyway. I don't think. Okay, so x equals negative 3 pi over 2. So we have 4 vertical asymptotes here. That's great. That's going to be plenty. All right, now let's just start plotting some points. Okay, so basically, let's start at 0. Okay, 0 is a good place to start. So secant of 0. What's the secant of 0? Secant of 0. So remember, this is going to help us out here. So if you don't really have that part of the unit circle memorized, the secants, I mean, if you don't have the secants memorized from the unit circle, maybe that's okay, but definitely have cosines memorized at least. So secant of 0 is 1 over cosine of 0, which is 1 over 1, which is 1. Okay. So basically, when x is 0, the corresponding y-coordinate on the graph is 1. Okay, that's what this tells us. So now we're just plotting points. Okay, so when x is 0, y equals 1. Okay, so 0, comma 1, that's a point on the graph of the secant function. Okay. Now let's look at pi over 6 next. Okay, pi over 6 will be next. Secant of pi over 6. Okay, secant of pi over 6. So this is the reciprocal of the cosine of pi over 6. Okay. And remember, the cosine of pi over 6 is root 3 over 2, so this is 1 over root 3 over 2. Okay. So if, divide by root 3 over 2, so that's really like 2 over root 3, or 2 root 3 over 3 if you insist on rationalizing the denominator, which I really don't, but anyway. So that doesn't really help us out that much, but if we can toss that to a calculator and see that's about equal to 1.1547-ish. Okay. So zoom in a little bit on that. So what we see is that when x is pi over 6, the corresponding y-coordinate is about 1.1547. So let's go ahead and plot that. So pi over 6, comma 1.1547. Okay, well here's 1, here's 2, so here's 1.5. So 1.1547 is actually pretty far down here. Okay, so it'll be right about there. Okay. How about next? Pi over 3 could be next, but let's do pi over 4. Where's pi over 4? Well, here's 0. Okay, 0 is right here. Here's 0. Here's pi over 2. Pi over 4 is exactly halfway in between them. Okay, because 0 plus pi over 2 is pi over 2. Take the average, divide them by 2, basically. So pi over 2 divided by 2 is pi over 4. So this right here is pi over 4. Okay. So if that's confusing, just think of it as like 1/2 and 1/4 instead. So 1/4 is halfway between 0 and 1/2. So similarly, multiply everything by pi. Pi over 4 is halfway between 0 and pi over 2. Okay. So anyway, what's the secant of pi over 4? Okay, so we'll come over here now. So the secant of pi over 4. That's going to be 1 over the cosine of pi over 4. And cosine of pi over 4 is root 2 over 2 if you insist on rationalizing the denominator. So if you flip that, you're going to get 2 over root 2, which can actually be simplified to just plain old root 2. Okay? So there's actually a few different ways to think about it. I don't want to get hung up on it because that's not really the point of the video. But anyway, secant of pi over 4 equals the square root of 2. And we have talked about stuff like that before in earlier videos. So anyway, square root of 2, again, that doesn't really help us, but it's approximately equal to 1.414-ish. Okay? So when x is pi over 4, corresponding y-coordinate is about 1.414. So let's go ahead and plot that. So pi over 4, here's x equals pi over 4, and then the corresponding y-coordinate is about 1.414. So that's kind of sort of about here-ish, kind of around there. Just under 1.5. Okay, just under 1.5. Okay, now how about pi over 3? So pi over 3, let's come down here then. Secant of pi over 3. So secant of pi over 3 is 1 over the cosine of pi over 3. Okay, and then after this, the tedium is going to stop for a little bit briefly, then we just want to make a point about something real quick, then get back to it just briefly. So cosine of pi over 3. Cosine of pi over 3, that's going to be 1/2, so this is 1 over 1/2. Okay, and then 1 divided by 1/2 is just 2. Okay, so when x is pi over 3, corresponding y-coordinate is 2. Okay, when x is pi over 3, corresponding y-coordinate is 2. So pi over 3 comma 2. Okay, oops. Pi over 3 comma 2, so that's right here. When x is pi over 3, this point right here, the corresponding y-coordinate is 2. Okay, so we have a few points. Let's go ahead and connect them now. So we'll connect them like this. And this is actually going to keep shooting upwards like this. So if you want to plot more points, you'll probably have to toss some stuff into a calculator to evaluate it more accurately. But that's what we're going to have here. Okay, so now basically, let's get away from plotting points for a bit. We'll have to come back to it just briefly, but let's get away from it for now. So what kind of function is secant? Secant, remember, secant of x is an even function. Okay, so what does it mean to be an even function? So if you're an even function, what's that mean about your graph? Well, before that, algebraically, what that means is that secant of negative x equals secant of just plain old x. Okay, so for example, secant of negative pi over 6 is the same thing as secant of positive pi over 6. Okay, so that's actually really good because what that means graphically is that the graph is symmetric over the y-axis. Okay, so if we take this graph and then flip it over the y-axis, we're just going to get a mirror image of what we have. Okay? So that's great, that's really helpful, because that's going to save us a lot of trouble now. So, okay, all this trouble that we just went through with plotting these points here, 0, pi over 6, pi over 4, pi over 3, finding all the y values, things like that. We could do that again with negative pi over 6, negative pi over 4, we'll put negative pi over 4 here. Negative pi over 3, we can do that again, but since secant of x is an even function, the graph is symmetric. Okay, the graph is going to be symmetric over the y-axis, so we can just take this piece, reflect it over the y-axis, and we're going to get another piece of the graph. So let's use that fact right here. Okay. So this point right here, pi over 6, comma 1.1547 approximately. Okay. So that's going to be reflected into this piece right here, negative pi over 6, comma 1.1547. Okay, so this piece, right, 0, comma 1, that point that's on the y-axis, that doesn't get reflected anywhere because it's on the y-axis. So if you're on the y-axis and you reflect over the y-axis, nothing happens. Okay, but here, this point gets reflected to this point right here gets reflected to this point right here. Okay, this point right here gets reflected to this point right here. And then when we connect these points, we see that we're going to have the exact same shape basically. Okay. And then fill it in and extend it so that it looks kind of symmetric. Okay, so we got this kind of thing going on. So it looks like kind of a parabola, but it's actually not, it's technically speaking not a parabola, but it does kind of have that same curvy U-ish type shape to it. So it does have that going on. Okay, so we have this so far. So we're graphing the secant function, remember this video is mostly going to be spent on the secant, then we'll talk about some other stuff too, and how to get cosecant, and we'll talk about why we're doing them in the same video. So anyway, what's next? So that's here, so we use the even odd properties there, that's really nice. So now we have to kind of worry about this part over here, okay? So now we're going to get back to plotting points a little bit. We'll just kind of go through it a little more quickly, because they're just points on the unit circle. It's relatively, it's more like a review, so we don't want to spend too much time on it. Okay, so now we figure out what's the secant of 2 pi over 3. Okay, so secant of 2 pi, secant of 2 pi over 3. Okay, so unit circle type thing, or it's the same thing as 1 over cosine of 2 pi over 3, but basically what that is, secant of 2 pi over 3 is going to be negative 2. Okay, secant of 2 pi over 3 is negative 2. Okay, so 2 pi over 3 comma negative 2. Okay, so again, if you're unsure of that, just think about cosine. So secant of 2 pi over 3, I got to think about it for a little bit, is 1 divided by the cosine of 2 pi over 3. Okay, and the cosine of 2 pi over 3 is negative 1/2. So 1 over negative 1/2 is going to be negative 2. Okay, so that's going to be this point right here. Next, let's maybe do this right in here. Whoops. So the next one is 5 pi over 6, but let's put the something over 4 just to kind of be thorough and complete. So this is pi over 4, so this one's going to be 3 pi over 4. Okay, this one here will be 3 pi over 4. And also, just while we're doing that, let's put 5 pi over 4. Okay, so between pi over 2 and pi is 3 pi over 4. Okay, between pi and 3 pi over 2 is 5 pi over 4. If you're not sure of that, just think about the unit circle. Okay. So, you know, if you look at a unit circle, you'll have pi over 2 and pi. Okay, so if we draw a unit circle real quick, pi over 2 will be right here, pi will be right here, okay? 3 pi over 4 is right here, okay? Exactly halfway in between them. Okay? And also here's pi, here's 3 pi over 2, exactly halfway in between is 5 pi over 4. Okay? Here's pi, here's 3 pi over 2, exactly halfway in between is 5 pi over 4. Okay, okay. So anyway, that's that. Now let's continue. So secant of 3 pi over 4. Oops. Okay, secant of 3 pi over 4. So that's going to equal negative root 2. okay, which is approximately equal to negative 1.414. Okay, so we'll go ahead and plot that point. So when x is 3 pi over 4, the corresponding y-coordinate is about negative 1.414. So 3 pi over 4 right here, corresponding y-coordinate right about here. Okay. Next, 5 pi over 6. Secant of 5 pi over 6. So that's going to be equal to, it's also a negative, it's going to be negative 2 root 3 over 3 if you insist on rationalizing the denominator, which I really don't, but I think most people might be into that or have to do that. So that's approximately equal to negative 1.1547. Okay. Okay, so we have that going on. So that's right about here. Okay, 5 pi over 6, corresponding y-coordinate is negative 1.1547, which is just below negative 1, right about here. Okay, now what about pi? Okay, pi is the next guy here. So secant of pi is going to be negative 1. Okay, because it's 1 over the cosine of pi. Cosine of pi is negative 1. So let's actually just write that out. So it's 1 over cosine of pi. Okay. And cosine of pi is negative 1. So 1 divided by negative 1 is negative 1. Okay. So pi comma negative 1 is a point on the graph here. Okay, let's fill in what we have so far. So this piece connects to that, or this point connects to that point like this, and then out like this, and then we'll extend what we have. Let's kind of try and make it a little more smooth and rounded. Okay, so kind of sort of something like that, right? So let's zoom out a bit and see what's going on here. Okay, so what we see actually is that we have this, zoom out a little more, so we have this kind of U-shaped piece right here, and we have what looks like half of another U-shaped piece. So actually what's going to happen is if we keep filling this in, it's going to be the exact same kind of shape. Okay, so just to spare us all the tedium of going through, plotting more points, we'll just fill in the rest of this piece here. So it is going to happen that if you keep plotting points, secant of 7 pi over 6 is about negative 1.1547. Secant of 5 pi over 4 is negative square root of 2, or about negative 1.414. Secant of 4 pi over 3 is exactly negative 2. Okay, so we get those same pieces again. Okay, now be careful, this isn't really symmetry properties here, it's not periodic properties, it's not symmetry properties. It's just a nice coincidence, really. Sort of. There's some stuff going on behind the scenes, but it's irrelevant. We don't want to worry about it. Okay, so anyway, that's what's going on here. Now, that's really all we have to graph for the secant function. Why is that? So let's say y equals secant of x. Now, why is that all we have to graph? Because of periodic properties, right? So here's negative pi over 2. Here's 3 pi over 2. What's the distance between them? Okay, well, 3 pi over 2. 3 pi over 2 minus negative pi over 2. Okay, so just do right minus left to get the distance between them. Well, that's going to be 3 pi over 2 plus pi over 2, which is 4 pi over 2, which is 2 pi. Okay, what's significant about that? Well, 2 pi is the period of secant. Okay, remember secant has period 2 pi. Okay, so basically this little piece that we just graphed here, so this piece up here and this piece down here, these two pieces together, that's one complete cycle of the secant graph. So if you move 2 pi units over, you're going to have that exact same thing. Okay, so 2 pi units over this way, you're going to have a U-shaped, a vertical asymptote, and then another U-shape, okay, upside down. So this whole thing here, including this U-shape, this vertical asymptote, and this U-shape, and I guess these asymptotes too, okay, they're all part of one complete cycle. Okay, so you move 2 pi units to the right, you'll have the same thing again. Move 2 pi units to the left, same thing again. Okay? So with that in mind, we can fill this in, but we can also use the even property to fill that in. Okay, so remember, since secant is an even function, the graph is symmetric over the y-axis. So what that means then is that if we take this entire piece here that we just drew, if we take that entire piece, reflect over the y-axis, we're going to get that exact same piece back. Okay, so two different ways of thinking about it, but same exact thing either way. Okay, so take this, reflect over the y-axis, we're going to get that exact same piece back. So that's going to be this point right here. Okay, so this point right here gets reflected to this point. Okay, this point right here gets reflected to this point right here. And then this point right here gets reflected to this point right here. This point over here is going to get reflected to this point right here. Okay, and then we can fill those in, or connect those dots there, and extend. Don't touch the vertical asymptote. Remember, never touch a vertical asymptote. And then this piece right here becomes, or gets reflected to this piece over here, this point right here, reflected to this point. This point right here gets reflected to this point over here. And then we can fill those in, connect those dots. Okay. And then we just have another piece exactly like that. Okay. So, we fill this in thinking about reflections, but also just think about the periodic properties. So here is one complete cycle. Okay, so here's one complete cycle like this, and then if we move to the left, we're going to have another complete cycle. So really, what we actually have then, if we go to the left, 2, 3, so what is there? There's 1, 2, 3, 4, 5, 6 to the next one. So 1, 2, 3, 4, 5, 6. So we'll have another vertical asymptote here. Okay, so another vertical asymptote here, and actually the next one, so negative pi over 2, negative 3 pi over 2, this is x equals negative 5 pi over 2. Okay, so because of the periodic properties, we know, we don't even have to label these really, so I'm not going to take the time to do it, but it's just going to be this point right here. Okay, so using periodic properties, this point is going to be shifted to this point gets shifted to this point is going to get shifted to this point right here. Okay. And then this point is going to get shifted to this point here. Okay, so we can fill those in, or connect those dots. I don't know why I keep saying that. Okay, and then likewise, this point right here gets shifted to this point. This point is going to be shifted to this point. And then this point right here is going to be shifted to this point. Okay, then we can fill those in. Or connect those dots. Man. Okay, so now we see two complete cycles here, okay? So here, this is one complete cycle. So here's our original cycle we started with. There's one complete cycle right there. Top piece, asymptote, bottom piece, asymptote, asymptote. And then here's another complete cycle, okay? 3 asymptotes and then piece up here, piece down here. Okay, so 2 complete cycles right there, and we see that's what's going on with the secant graph. Now, what's really nice about this, well actually before we talk about what's nice about it, let's go ahead and get the graph of the cosecant function. Okay, so we're going to get the graph of the cosecant function, and then we're going to talk about good ways to tell them apart. So here's the secant graph, so let's go ahead and start with that. Okay, so here's a graph of the, so it's going to be just kind of like a rough sketch. So this right here, okay, so here's the function y equals, we'll put some asymptotes in here too. Okay, so this is 1.5 complete cycles. But anyway, this is the function y equals the secant of x. Okay, we just drew it, we just saw how to get the shape and everything. Okay, so this is y equals the secant of x. Okay, okay, now what I want to do is take this graph and shift it a little bit. So we're pretty much just going to do the exact same thing we did when we got the graph of the cotangent function from the graph of tangent. So we're going to shift this. So now what I want to graph is y equals secant of x plus pi over 2. Okay. Okay, but I guess before we move on, so it's kind of bad practice what I just did up here, but what we should do is label these asymptotes, so that's going to help us also. So that's x equals pi over 2, x equals 3 pi over 2. This is x equals negative pi over 2, and this is x equals negative 3 pi over 2. Okay. Okay, so that's going to help us when we do the shifting. So secant of x plus pi over 2, remember this kind of shift, so if you do x plus something, that's going to shift it to the left. So if you have a graph of a function f of x, then like f of x plus 3 is going to shift the graph 3 units to the left. Okay, sort of behaves backwards from how you might expect. Okay, so f of x plus 3 like that shifts it 3 to the left. So here, secant of x plus pi over 2 shifts pi over 2 units to the left. Okay, so remember that's like a pre-calculus college algebra type thing. So let's go ahead and graph what that looks like. So Okay, let me maybe write that smaller or somewhere else. Okay, so then we have this going on. So here's x-axis, y-axis. So now I'm graphing y equals secant of x plus pi over 2. Okay, so I'm just going to take this graph up here and shift it to the left by pi over 2 units. Okay, so it's going to be relatively straightforward. So this right here may have been easier actually to start with the asymptotes, but we're just making rough sketches. And this intermediate step actually isn't really that important, so we don't have to worry about it too much. Okay, but anyway, shift everything over to the left by pi over 2 units. But actually, yeah, in general, it's probably better to start with the asymptotes so you have a guide to work with. It's easier as a guide. So here, x equals pi over 2, if we shift that to the left pi over 2 units, that's going to become x equals 0, right? X equals 0. X equals 3 pi over 2, if we shift that to the left by pi over 2 units, what's that going to become? Well, 3 pi over 2 minus pi over 2 is 2 pi over 2, which is pi. Okay, so this is x equals pi. Okay. Now how about over here? What's this asymptote right here? Well, this, so we took everything shifted to the left, so actually x equals negative 3 pi over 2 got shifted kind of off the graph. It's farther to the left than we're drawing, but now these three here, so this one got shifted to x equals 0, this one got shifted to x equals pi, so what about this one here? Well, negative pi over 2 shift to the left by pi over 2 units, so negative pi over 2 minus pi over 2, that's negative 2 pi over 2, which is negative pi. So this is x equals negative pi. Okay. Okay. All right, so we have that going on there. So now one last thing to do before we can get the graph of the cosecant function. So let's box this off here. All right, now what I want to do is one last thing. So I want to take y equals secant of negative x plus pi over 2. Okay, so remember from pre-calculus college algebra, remember from those days, that if you put a negative sign in front of the x, basically that's like multiplying all your x coordinates by -1, more or less, that's what that's doing. So if you do that to your x coordinates, then you reflect over the y-axis, okay? So if I have an x, I make the x negative, then instead of going to the right, I go to the left. Okay, so reflect over the y-axis. Okay, so again, secant of negative x plus pi over 2. I'm going to take this graph here that I just made and reflect it over the y-axis. Okay, so then what I'm going to get, let's go ahead and make our axes here. So x-axis, y-axis, okay. So first let's look at the asymptotes. So if I reflect x equals 0 over the y-axis, what's happening to it? Nothing. X equals 0 is the y-axis. If you reflect something over itself, nothing happens to it. Okay, so we still have that asymptote there. That's good. So that's x equals 0. If we take x equals negative pi and reflect it over the y-axis, what happens to it? Nothing. Or, well, sorry, not nothing, but, well, in this case, nothing is going to happen to the graph, but x equals negative pi, that's going to get reflected to x equals pi. But x equals pi is already a vertical asymptote, so nothing different is happening, is what I meant. So x equals negative pi, x equals pi, when you reflect, they just reflect over onto each other. Okay, so actually, if we take this and just flip it over the y-axis, the asymptotes stay the same, is what's going to happen, basically. Okay. So x equals pi, and then x equals negative pi is still there. Oops, it's maybe a little more to the left. Okay, so that's x equals negative pi. All right, so, and again, you know, all we did was we just take this and reflect over the y-axis, so just flip it around like that, flip like that, and then that's what we're going to have. So now the asymptotes stayed completely the same. Nothing changed with them. That's kind of good in a way. So what happens now to the pieces of the graph? Well, if we take and reflect over the y-axis, this piece up here is going to get reflected into here. Okay, so this piece up here gets reflected to over here. So let's move that. So it's going to get reflected to over here. Okay. And that's the y-axis. Okay, so again, we reflected so this negative in front of the x sign, that reflected everything over the y-axis. So the asymptotes stay the same. This piece got reflected over to this piece. What's going to happen to this piece is going to get reflected into here. Okay, so this piece gets reflected into here now. So that's going to happen there. Okay. And then likewise, this piece over here is going to get reflected, you know, if we reflect this over, so it's going to get reflected over into here, okay, into here, down here. So that's down over here, basically. Okay, so that's what's going on there. Now, what's so significant about this? So again, just to recap real quick, so this piece right here, we reflect it over the y-axis, it's going to be reflected all the way into this piece here, which is this right over here, okay, right, just to the right of x equals pi. Okay, so what's going on here now? What's significant about that? Well, remember the complementary angle theorem? So complementary angles, that's the shorthand notation for angle, complementary angle theorem says a lot of things, but one thing, well, it says a few things, but one of the things, the only thing that's important here is that secant of pi over 2 minus x equals cosecant of x. Okay, why is that important here? Well, here, look at this. Secant of negative x plus pi over 2. Okay, well, negative x plus pi over 2, that's the same thing as saying pi over 2 minus x. Okay. But secant of pi over 2 minus x, from the complementary angle theorem, that is the cosecant of x. Okay, that is the cosecant of x. Okay, so what we've actually graphed here was y equals the cosecant of x. Oops. Cosecant of x. Okay, so that's that. And we see cosecant has asymptotes at negative pi, x equals negative pi, x equals 0, x equals pi. Now, why did I do that in the same video as secant? So that's what I want to talk about now, just real quick. So here, let's go back to this graph here. Yeah, well, actually, we don't really have to do that. Let's look at here. Here's the graph of our secant function that we started with. Let me maybe move this up just a little bit, because there's something I want to do with that. Okay. So I want to make it a little more accurate at least. So anyway, we have that there. Now, here's the graph of the secant function right here. Here's the graph of the cosecant function right here. They look pretty similar, right? And they might be kind of hard to tell which one's which. But what you could do is remember secant is 1 over the cosine of x. Okay, so remember that at least. Remember that secant is 1 over the cosine of x. Okay, so definitely always remember that. And then remember what the graph of the cosine looks like. What happens if we graph secant and cosine together? Well, let's go back to our graph over here and graph them together. Okay, so here's the graph of the secant function. So now what I want to do is graph cosine with it. So if I graph cosine with this, let me see if red will work. Yeah, we'll try to use red. Okay, so if I graph cosine on here, what's cosine going to look like? Cosine is going to kind of sort of look something like this. Okay, so do you notice anything awesome about that? Yeah, this is totally super awesome. I think so anyway. So notice what the cosine function is doing. Okay, so let's zoom in here. Okay, and what we see is that cosine and secant, they touch each other at these points where the y-coordinate is 1 or negative 1. Okay, so this is 0, 1, the graphs are touching. This is pi, negative 1, the graphs are touching. This would be 2 pi, 1 right here. And if we extend the graph a little bit, the graphs will be touching right here. Okay, so we extend the graph up here, extend up here. Okay, the graphs will be touching. Okay, and we'll have another vertical asymptote here. But anyway, so the graphs are touching there, and the graphs are also touching at negative pi, negative 1, and negative 2 pi, positive 1. Okay, they're touching. And also notice that whenever cosine is 0, secant has a vertical asymptote, which we've already talked about in this video. So whenever the cosine function is 0, secant is 1 over 0, which means vertical asymptote. And we see that right here. Okay, so this red graph, which we can extend, put an arrow, so that's y equals cosine of x. Okay. Okay, so what we see then, so we'll zoom out a little bit here, and what we can see is that when cosine is 0, right here, right here, right here, and right here, and right here, okay, secant has a vertical asymptote. Okay? So that's great because actually cosecant and sine behave the exact same way together. So we don't have a nicely scaled picture to work with for cosecant, but let's zoom out a bit and we'll come back over here. Okay, so I've already used red there, so let's maybe use blue. So remember cosecant, well, cosecant is 1 divided by the sine of x, right? So if we want to graph the sine of x together with cosecant, remember the sine of x it has the same exact shape as cosine, just shifted a little bit, okay? So definitely remember that cosecant is 1 over the sine of x, and definitely want to remember how the graph of the sine function looks, and it looks kind of sort of something like this. Okay. So horribly not to scale because of just the way I drew it, but anyway, that's what's going on here. So extend this way, arrow that way, and then extend down here. They're going to touch here, and then arrow up this way. Okay, so we see that this right here is the graph of the sine function. So let me maybe actually extend one more complete cycle. So this here is y equals cosecant of x. I'll erase that. And let me put another thing right here. Okay, and then another asymptote right here. And I totally forgot the other arrow. Okay. Put that back. Extend and then label the asymptotes. So this asymptote is going to be x equals negative 2 pi. Okay. Remember this, okay, so x equals 0, x equals pi, x equals negative 2 pi would be the next one. So then if we continue with the sine graph here, it's going to keep going up like this, and then if I were better at drawing it, which I think most of you guys know by now that I'm not any good at that. So anyway, we have that. So this here, this is y equals sine of x. Okay. And what do we see for the sine of x? Well, we see the relationship is exactly the same as with secant and cosine. Okay, the graphs anyway. So here, these are touching where the y-coordinate is 1. Okay, this is the point, this here is pi over 2, so this is pi over 2, comma 1. Okay, this here is 3 pi over 2. So this right here, this point is 3 pi over 2, comma negative 1. Okay, this is negative pi over 2. So this is negative pi over 2, comma negative 1. The graphs are touching there. And then this here is negative 3 pi over 2. Okay, that x value is negative 3 pi over 2. So this point is negative 3 pi over 2, comma positive 1. Okay, and again, just like with cosine and secant, we see that where sine of x is 0, right here, right here, right here, and right here, we see that where sine of x is 0, and also right here, I didn't draw the asymptote though, we see that cosecant has vertical asymptotes. Okay, so this is x equals 2 pi. Okay, so the sine of 2 pi is 0, and cosecant has a vertical asymptote there. Sine of pi is 0, cosecant has a vertical asymptote. Sine of 0 is 0, cosecant has a vertical asymptote. Sine of negative pi is 0, sine of negative 2 pi is 0. Vertical asymptotes on the cosecant there. Okay? So cosine and secant have that great relationship, and sine and cosecant also, they have that same relationship. Okay, everything's really nice there. So if you're unsure, you know, here's secant, looks kind of like that. Here's cosecant, it has that same shape, just shift a little bit. If you have trouble remembering which one's which, just remember cosine and sine, okay? And cosine and sine, you'll definitely want to be able to tell those apart because they're pretty, you know, they're pretty much the two most basic functions in trig. And just remember that sine of 0 is 0, so this one goes through the origin. Cosine of 0 is 1, so this one starts up here like that and goes around like that. So anyway, that's how you can tell those two apart. And then once you have cosine plotted, you can get the secant graph from that, okay? And then once you have sine plotted, you can get the cosecant graph from that. Okay, so that's why I did both of these together in the same video, because they look pretty similar, but when we point these out together, it's good to see these side by side and just see that, okay, if I graph cosine, then I can get secant like this. Remember, they touch where the y-coordinate is 1 or negative 1. Okay, so they touch here, 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 and here, and here. And likewise, the sine graph and the cosecant graph touch where the y-coordinate is 1 or negative 1. So here, 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 and here. And it just keeps happening forever to the right, forever to the left because of the periodic properties. And wherever cosine is 0, secant has vertical asymptotes. And wherever sine is 0, cosecant has vertical asymptotes. Okay, so that's the graphs of the secant and the cosecant functions, and some videos about the properties coming up next.